All right, good morning. This lesson is for my Integrated 1 class. This is for lesson 14, I believe. This is going to be our second lesson on the angle, side angle, triangle congruence criteria. Before I get started, I want to say I hope everyone's doing okay out there. Again, I did reach out to a few of you, trying to, for some of you, encourage you to get more work done. Others of you, I told you keep up the good work. Let's keep doing what we're doing. Remember, the goal is we want to get credit when this is all said and done. And so I just wanted to reach out to some of you who I felt were on the bubble and kind of guide you in the right direction, or just encourage you to keep doing what you've been doing. So anyways, again, I hope everyone is doing all right. Let me talk about our goals today, and I want to just double check this camera. I've been having a heck of a time with this tripod, and it stayed still. All right. So we have two goals today. Again, this lesson is only about the angle side angle, right? And the angle side angle, remember, we're looking for this congruence pattern. I've had a couple of you reach out to me for questions on the homework, and I really don't think you guys understand that this pattern is what we're looking for. If we don't have this pattern, then the triangles aren't congruent, and that's it. Or we have to say what we have to add to get this pattern, okay? Remember, this mark means that this angle is the same as that. This mark means that this side is the same as that. These two arcs mean that this angle is the same as that, right? Angle, side, angle. The side has to be between the two angles. It doesn't work if the side is outside the two angles, okay? All right, so our first goal is to find hidden congruent angles because of vertical angles. Our second goal is to find hidden congruent sides because of reflexive property. Again, these identical angles can be hidden in the picture, and I want to show you how they're going to be hidden. So let me just review with you guys. I'll talk about my first goal. Let me review. I'm having a hard time talking with you guys the concept of vertical angles. So if I have two lines that cross, I get four angles, but I'm only talking about three of them. Angle 1, angle 2, and angle 3. And if I just kind of ignore this part, I get this idea. And if I ignore this part, I get this idea. And if you notice right here, I have a straight line, which is a straight angle. And what that means is that the angle 1 and the angle 2 add up to 180 degrees, because if I add these two angles together, I get a straight angle. Remember, how much they open is how much they measure. So this angle opens up with this angle, and they make a straight line. So that means that these two angles together must add up to 180 degrees. The same thing happens for angle 2 and 3. The amount that angle 2 opens up with the amount that angle 3 opens up makes a straight line. So we can also say that angle 2 and angle 3 add up to 180 degrees. And remember, when two angles add up to 180 degrees, we call that supplementary. Okay? So we have this argument style. It's called the transitive, and I'm not going to get too much into the argument style today because this lesson is again about angle, side, angle. But if two things are equal to the same thing, then those two things themselves must be equal, right? Like two $10 bills is a $20 bill. Four $5 bills is a $20 bill. So we could argue that two $10 bills must be the same as four $5 bills because both of those are equal to a $20 bill. So I know that this must be now equal to this, which I set this equation up. And since both sides of the equation have a measure of angle 2, we can subtract that away, and we get measure 1 equals measure of angle 3. And what I just did was I did a very, superficial argument that vertical angles are congruent. So anytime you see vertical angles, we know that vertical angles, they are congruent. Okay? So you're going to see pictures like this in your homework. And again, remember, this is an angle, side angle, triangle congruence criteria. So if you see this, I've hidden the fact that this angle must be the same as that angle because these angles are vertical angles. This hidden congruence is in the picture. So you're going to have to pick up on that. Again, if I have triangles that are connected in this manner, angle 4 and 5, those are vertical angles, just like 1 and 3 are. And we saw that 1 and 3 must be equal because they're vertical, so 4 and 5 are vertical angles, so we can reason that they must be equal. And since they're equal, we know that they must be congruent, and I now have a hidden congruence. So this is one of the ways that I'm going to hide congruences in this assignment. Okay, so I'm going to check off the first goal. Alright, so again, we're trying to build to this congruence pattern, and I'm going to hide congruent angles in the picture. Maybe the situation, I'll just finish with this on the congruent. Maybe you have a set of angles that are congruent already. What you're going to have to do is you're going to have to say that this angle and this angle are congruent with the 2 marks, because you've already used the 1 mark. You can't use a 1 mark everywhere. Alright, so that's how I'm going to hide congruent angles in this lesson. Okay, they're going to be hidden using vertical angles. Alright, let's move on to our second goal, and it's find hidden sides because of the reflexive property. Alright, let's see. So, let me just kind of talk about the word reflexive. Reflexive reminds me of a reflection, and when you see a reflection of in the mirror, you see yourself, right? And so the reflexive property, it's basically saying something is the same as itself. Okay, so that's kind of the idea here, right? Let me get out of the way. And again, this is a way that I hide congruent sides. Okay, so reflexive property, the idea is something is the same as itself. You know, and if something is the same as itself, that's a real, you know, we're basically saying that thing is congruent. So, you know, when you're looking at yourself in the mirror, you know, you can honestly say, dang, I'm looking congruent today, because your reflection in the mirror is the same size and the same shape. Unless you have a wacky mirror, and then we're now talking about dilations. But again, something is the same as itself. It's a way that we can talk about congruence. And again, it's a way that I'm going to hide a congruence in a shape. So let me draw a triangle here. I hid that marker I wanted to use for myself. Though I'm at home, I still hide things for myself. Where did I do it? Marker, what about you? Okay, well, I'll just use this one then. Okay. So, the way that the picture will look for reflexive is you're going to have something that looks like this. And you're going to have 2 triangles that are actually sharing a side. Okay, so this side right here, the length from A to B, that side is in both of these triangles. And you could actually think of it like, you know, you could split the triangle into 2. But again, this side AB is the same as itself, and since it's the same as itself, we can consider this a congruent side. All right. So in the pictures, if you see something like this, you know that you've got a hidden congruence, and so this side is going to be congruent to itself, and so that's a way that I'm going to hide a hidden side congruence in this. Again, this lesson is about this congruence pattern. I thought that the first lesson it would be good just to see the triangles separated, and I felt that for this assignment it would be good to have the triangles have the hidden congruences by vertical angles or with the reflexive property. Alright, so again, vertical angles are a way that I'm going to hide a congruence as well as the reflexive property, right? And we need this to be between the congruent angles for it to be angle side angle. And again, I hope everyone's doing okay out there. I'm going to post this video right here in the next few minutes. And if there's any questions or anything I can help you with, please reach out. And let's just make sure we're doing the best we can in this. And have a good day, everybody.